Why do we need macro channel? Simple, right? Macro channel is to enable routing, right? Or avoid congestion. So there are different types of channels in our design. When we actually do the project, there will be different types of channels in our designs, and we have to use the channels to our advantage. Okay, meaning first thing is, let us say we are having ports here and we put a macro here. So ports are nothing but they have to get routed, right? You all know what is routing. These have to get routed. Let us say all these ports have to connect to the core area. There is some module here. These have to connect to the core area. So all these ports will have vertical routing first, sorry, horizontal routing first, because these are horizontal, and then they have to go vertically, and then they have to go again horizontally. So first part is horizontal, then vertical, then horizontal. Let us say I have 100 ports here. What will happen? For all the 100 ports, there will be a first horizontal wire, and then again a vertical wire, and then again a horizontal wire to go to the core area. Some ports can go like this also. This will also be horizontal, vertical, and horizontal, and then again vertical. Right? If you see, the routing for all the 100 ports is happening in this gap between the core and the macro. There is a macro here, and all the 100 ports routing is happening between the vertical routing. Horizontal is fine. All the 100 port vertical routing is happening between the core and the macro. Now, let us say we have some 6 layers for, or let us say we have 4 layers for routing. M1 is given for follow pin, and M7 and M6 for power. I'm just taking it for example. M1 for follow pin, M7 and M6 for power. Now we have M2, M3, M4, M5. Since M1 is horizontal, M2 will be vertical, M3 will be horizontal, M4 will be vertical, M5 will be horizontal. So we have M2 and M4, two vertical layers to route this all 100 pins, right? So we have two routing layers to route all the 100 pins. Got it? Now, let us say we do not know how the tool will use M2 and M4. Tool usage we do not know. Means the tool can use all the 100 nets in M4, or the tool can use all the 100 nets in M2, or the tool can split 50 of them or 40 of them in M2, 60 of them in M4. Right? Can we guide that? Yes, we can guide the tool and say for these net names use M4, and for the rest of the net names your choice. Or we can say for all these 100 nets, for each net use this layer. We can guide that, but it is a very tedious process, right? We cannot guide every net in the design. Otherwise, what is the point of routing, right? We can only manually route. The tool has to choose appropriate layers for the design, right? Now, for routing these 100 nets, let us say M4 we all know that the thickness of the nets will keep on increasing from M1 to M1 upwards, right? Let us say M1 is 0.5 microns, M2 will be 0.7, M3 will be 0.8, right? The width of the metal layers will keep on increasing as we go higher. Everyone with me, or you have any doubts? Everyone with me?
Yes, sir.
Yeah. Let us,
Yes.
so let us say M2 is 1 micron width. M2 is 1 micron width. M4 is 2 microns width. Just an example. So M2 is 1 micron width. M4 is 2 microns width. Now we don't know how tool is going to route. If it's going to route 100 in 1 or 40 and 60, we don't know that. Let us say, for example, tool has routed all 100 pins vertical nets, okay, in M2. Worst case scenario, tool has routed all 100 pins vertical nets or all 100 vertical nets in M2. In M2, you must have seen that this is there will be tracks. So this is one M2, this is the other M2, right? And this is the third M2, right? If you have seen layers, M2 will all be in single layer, right? Or single planar this thing, right? And we call this as the from the center of one net to the center of other net. What do we call?
Pinch.
Exactly. This is the pitch of M2, right? So if I say all 100 nets are being routed on M2, so on till 100, and all 100 nets are routed on M2. These are 100 nets. Now what will happen to accommodate all these nets? Okay, to accommodate all these nets, how much space is required? Let us calculate. So pitch of M2 is 1 micron, and let us say spacing is another 1 micron. So width is 1 micron and spacing is 1 micron. This width, since pitch is center to center, it is 1 micron by 2 plus 1 micron by 2 plus spacing is 1 micron, which is nothing but 2 microns. You're able to follow? From the center of one M2 to the center of another M2, it will be 2 microns. Pitch is equal to 2 microns. Fine. Everyone able to follow? Now when pitch is 2 microns and I have 100 nets, which means I have to multiply 2 into 100. How much is it is? 200 microns. Okay. So 200 microns is the total space required in metal 2, or in the core area. I need 200 microns if I have to route all the layers in metal 2, all the pins in metal 2, right? Let us say now take metal 4, similar to metal 4, similar to metal 2. Let us now take metal 4. Hundred. Here, like I said, width is 2 microns, which means Half of the width is 1 micron. Again, half of the width is 1 micron. So that is 2 microns. And then spacing is 2 microns. So pitch will be half of the width is 1 micron plus half of the width is 1 micron plus spacing is 2 microns, which is 4 microns. For metal 4, pitch will be 4 microns. And this is for metal 2. Now if it is 4 microns and there are 100 nets, what is the total space required? Total space required is 100 into 4, which is 400 microns. Right? But the tool is not stupid to route everything in metal 4 or everything in metal 2. Right? So it will divide between metal 2 and metal 4. It will divide the vertical nets between metal 2 and metal 4. So we cannot take all nets in metal 2 or we cannot take all nets in metal 4. So what I will do, I will average these out and take the average, right? So here, look at this, whatever we have done, we have taken the number of nets, 100 is nothing but the number of nets, into pitch of metal 4, okay, to find out the space. But since I have two metal layers, metal 4 and metal 2, all 100 nets won't be routed in metal 4 or metal 2. So in metal 4, how many nets will be routed? I will average this out, 100 by 2. Okay. Now this becomes 50 nets. This 2 is nothing but number of available layers. Right? Simple. I have 100 nets in my design. They need a vertical route to go into the core area. Right? First route is horizontal, but second route will be vertical to actually go into the core area because there is a macro here. So that vertical route for 100 nets can happen in only two layers, M2 and M4, because only two of them are vertical, rest are horizontal. M2 is 1 micron in width, M4 is 2 micron in width. Now for 100 nets, if all of them have to be routed in M2, it will be 200 microns. If all of them have to be routed in M4, it will be 400 microns. Right? Now, all of them won't be routed in 2 or in 4. So I have to divide the nets between 2 and 4. Right? Since I have two layers available, I will just divide the number of nets by number of available layers, which is 2 and 4. Simple. All nets will not be in single layer. So I will divide it by number 2. So that will be 50 into pitch of metal 4 will be 4, which is again 200 microns. Looking at this, do you remember any formula? Are you able to recollect any formula?
Spacing between the macros.
Absolutely. Formula for channel spacing. Now you understood how the formula is derived. It is simply trying to figure out how many routing resources are required and how much space is required for the routing resources. So from this, what we can say is, first one is number of nets. Since every pin has to be routed, instead of number of nets, we will say number of pins. Number of nets is equal to number of pins. So number of pins into pitch. Pitch, we have metal 2 pitch and metal 4 pitch. But we have to be pessimistic here. So we will consider metal 4 pitch. We will consider metal 4 pitch. So we will say pitch of highest routable layer. Since metal 6 is also highest layer, but it is not routable, right? It is used for power. So we cannot take metal 6 pitch. We will only take metal 4 pitch. So number of pins into pitch of the highest routable layer. Now all pins won't be routed in metal 2, right? Some pins will be routed in metal 4, metal 2, etc. So what I will do, I will divide it with number of routable vertical layers. But how do I calculate vertical or horizontal? So what I will do is, I will remove these vertical layers, and what I will say is number of layers by 2, because in my design one layer will be horizontal, one layer will be vertical, horizontal, vertical. So if I have 4 layers or if I have 6 layers, how many vertical layers will be there is by 2. 3 layers will be vertical. So I will just take number of layers by 2. So this is the formula for channel spacing. It is not only used for macro to macro, you can use it for macro to ports also, right? As we have just seen, wherever you want a channel and you want to know how much space should I give in the channel, you can use this formula, or you can easily derive how much space is required, just like we have derived now. You're able to follow? Is it easy? Is it easy? We have just derived the formula from first principles. I just wanted to know how much space is required. I just tried to calculate the space, and I was able to come up with the formula.